Welcome back to another daily lesson. Again, we're bringing a lesson here related to our unit on chemical equations and chemical reactions. So we see here some specific goals for this unit, or at least this segment of the unit.
His palms are sweaty, knees weak, arms are heavy. There's vomit on his sweater already. Mom's spaghetti.
So we're going to be taking a look today at a skill. Actually, the skill is something that a lot of students, when they're first introduced to it, have a little bit of a challenge with it. It's called balancing an equation. You have very specific goals in mind for today's lesson. Specifically, how do you do it? What's the fundamental law or idea that requires us to do it? And eventually we'll learn how to apply some specific strategies. For today, it's going to be sort of trial and error based, so that'll be okay. That'll kind of get you to begin to recognize that sometimes a strategy might be a better way to go about it. So let's get right underway with specifically what I'd like you to learn today. So the idea is called a balanced equation. What we just recently learned was something about something called a skeleton equation, and a balanced equation provides a little bit more detail than a skeleton equation would, and that's really what I'd like us to kind of latch on to before we begin. So what is this thing called a balanced equation? Well, it's a way to use symbols to represent the formula for every reactant and every product in a chemical reaction. What it's going to do is it's going to use something that are called coefficients, which we've been introduced to before. Coefficients represent quantities. Specifically, we might want to think about them as being the quantity of particles. And there's a definite reason for it. Every chemical reaction has to obey this fundamental principle called the law of conservation, which means we don't create atoms, we don't destroy them. We simply rearrange them to create new chemicals. So here we're looking at some particles down near the bottom of the screen represented by these reactants and this product. The reactant hydrogen represented by the blue molecule, the reactant oxygen represented by the red molecule. This blue molecule and red molecule, they rearrange and they form a water molecule, but you're going to notice that the quantity is not correct. It looks like one of the red atoms in the oxygen molecule disappeared. Well, that's because what's written down here is something called the skeleton equation and not the balanced equation. And what the balanced equation provides are coefficients, the numbers written in front that tell us the specific particle quantities. So if we were to look at the balanced equation for this would have a 2 for hydrogen and a 2 for water. And what that does is it reveals the particle ratio. There would be 2 hydrogen molecules needed for this reaction to occur. And what that would do is it would create 2 water molecules. So there's a ratio of 2 hydrogen, even though there's no number here, it's an assumed 1. 2 for 1 creates 2. So there's a ratio revealed by what we call the coefficients, and that's what we're going to learn. How do we write these coefficients? So I'm going to try to give you a little bit of a strategy that will become sort of trial and error based at first, and then we'll make strategies more specific for it. So we want to go from skeleton version to balanced version. So here is our reaction. It's called a skeleton equation. What we want to pay attention to are the small numbers that we call subscripts. For instance, here for oxygen, there's a 2 over here on the reactant side. But over on the product side, you see that there's no subscript for oxygen. So we assume that means there's 1. So a good place to start with this would be to just think about what the skeleton equation provides. Once again, it provides the correct formula for every reactant and every product. So we're not allowed to change the formulas. The formulas already exist. MgO, we can't change that by adding numbers to Mg or adding numbers to O. O2, we can't cross that out and make it a 5 or a 1. We're fixed into using these formulas. So what I like to say when we first begin this with students is you want to take an inventory of what elements participate in the reaction. This is a simple reaction involving only 2 elements, magnesium and oxygen. So down here below the skeleton equation, I like to create a little inventory when we first learn this. So our inventory includes magnesium and oxygen. These are the 2 elements. By inventory, what we want to do is we want to list clearly the quantity on the reactant side over here where oxygen is, and over on the product side where oxygen is. So what we're going to do is we're going to reveal the quantities of all of the elements that participate. So for magnesium, we notice there's no subscript, no number after magnesium, which means over here on the left side of the arrow, we know that there's only one magnesium. So what we're going to consider, this symbol here, on the left side of the symbol, we're going to consider the quantity of the reactant. On the right side of the symbol, we're going to consider the quantity of the product, and we're going to look to see if they're the same. If they're the same, that's what we call balanced, and that's what the goal is, to make the quantity on the left side, called the reactant side, the same quantity on the product side. So if I look over here on the reactant side where Mg is in the skeleton equation, there's only one magnesium. So in my inventory, I put a 1 for the reactant side on the left. On the product side, I come over here and I look at magnesium. I also notice there's no number written after Mg. So that tells me that there's one magnesium on the product side as well. Well, for magnesium, it looks like our reaction is balanced. We got the same quantity of reactant as we do product. Let's do our inventory for oxygen. Over here on the left side of the arrow, oxygen, there's a subscript of 2 that belongs to oxygen. So the quantity on the left side would be 2. Let's move over to our product side. There's no subscript with the oxygen, so that's assumed that there's 1 now. Notice that's not balanced. So the idea would be to add information, and specifically all you're allowed to add are what we call coefficients, numbers on these spaces or lines that would actually tell us the quantity of particles. So we're looking to add a number that could change the oxygen amount. So since oxygen amount on the right side is not the same as it is on the left side, there's 2 over here on the left side, but only 1 on the right side. You can actually view that in the particles that I've drawn up here. There's 2 O's in blue versus only 1. So we're allowed to write a number right here on this space. That number is called the coefficient. That becomes a multiplier for everything behind it. So this chemical, I'm going to put coefficient 2 here. What that does is that multiplies the oxygen amount. There was 1 oxygen. Now 2 times that initial 1 that was there doubles the oxygen quantity. So we cross off this inventory for 1 for oxygen. By putting the 2 in front, it makes 2 oxygen. So now we've balanced the oxygen amount. But notice what we've done is we've created an additional MgO, or an additional formula unit of magnesium oxide. That also multiplied the amount of Mg, because the particle comes in this package, 1 Mg and 1 O joined together. So what we then do is now we look over and we take notice that we've changed the inventory for magnesium on the product side. There are now 2 magnesium as product, 2 black particles, but there's still only 1 as magnesium on the left side as reactant. So we can fix that by writing a coefficient in this space where magnesium exists. So we're going to choose the coefficient 2, and what that does is that multiplies this chemical amount by 2. 2 times the 1 magnesium that used to be there now makes 2 magnesium. Notice we've balanced both magnesium and oxygen, and we have what's called the balanced equation. And the balanced equation has coefficients, 2 magnesium, 2 black dots, 1 molecule of oxygen, 1 molecule joined together, makes 2 formula units of MgO. So we think about the coefficient ratio as being 2 for 1 makes 2. Notice we don't always write this 1. This 1 is sort of an assumed value. Technically, it's kind of like a spelling error to put it there. So I'm not going to write it. For now, as you learn it, if you wish to provide one when you want to put it in there, I'd be okay with that. If you'd like to put it in there, excuse me. So our balanced equation reveals we would need a 2 to 1, and that would create a 2 ratio. 2 particles, 1 particle, make 2 particles. let's look at it from a different skeleton equation, or with a different skeleton equation. So again, the idea is the skeleton equation provides the correct formulas for how the particles would look in nature. So they would look N2, two N's joined together, H2, two H's joined together would make NH3. Well, when we balance the skeleton equation, these are the only packages we're allowed to use: a particle of NH3, a particle of H2, or a particle of N2. And what we can do is change the quantity of these packages that we have available. So first thing we should do is take our inventory of what elements participate. So our inventory has the elements nitrogen and the elements hydrogen. Now we're going to look on the left side, and we're going to find the quantity of nitrogen on the reactant side. Notice there's a 2, subscript 2. So there's 2 nitrogen on the reactant side. Let's go over here to the product side. Notice there's no subscript written after N. There's a 3 here, but that belongs to H only. So N, the quantity of N on the right side, on the product side, would be 1. That's not balanced. So we know we're going to have to fix that later. Let's take our inventory for hydrogen. On the left side here, hydrogen shows there are 2. So we write a 2 over here on the left side of our H in our inventory. Let's go over to our product side. It looks like there are 3 H's, so let's record that in our inventory. So neither nitrogen nor hydrogen are balanced in this case. Well, we fix that or correct that by adding coefficients. We're not going to change the formulas that are written. We're going to write numbers in front that are called coefficients. So where do we begin? Well, there really aren't any hard rules about where to begin, but we know nitrogen's not balanced. So why don't we begin with the nitrogen? We see that there's 2 nitrogen particles on the left side, but only 1 on the right side. So that's going to make, or tell me, a multiplier would be needed. So I'm going to choose the coefficient 2, because what that's going to do is that's going to double the amount of nitrogen that used to be here. Since there used to be 1 nitrogen, right, we're now going to double that. So that means there are now 2 particles of this chemical. So what that does is it changes the available amount of nitrogen to the quantity of 2, the 2 black particles. So now our nitrogen is balanced. Keep in mind what this also did is this changed the hydrogen amount, because it doubled the amount of hydrogen that used to be there. So 2 times 3 for hydrogen. Now there's no longer 3 hydrogen on the product side. Now there's actually 6. That actually means on the reactant side, we need to balance. We would need to have 6. If you look over here, we only have 2, which is what we wrote in our inventory. There are only 2. So we're going to choose a coefficient to write here in front of hydrogen that is a multiplier to multiply the 2 that are already there to create 6. So what we're writing there is a multiplier. We're not writing how many we need to add. We're writing the multiplier that we would need to create 6. So of course you came up with 3. 3 times 2 would make the 6 that we would need. So we would change the quantity now from 2 to 6, because what we did is we tripled the amount of particles that we began with. So now we see there's 2, 4, 6 red, 3, 6 red. Red represents the hydrogen element, and we have the balanced equation with coefficients that reveal the correct quantities. So our coefficients would be 1 to 3 ratio creates 2. 1 to 3 to 2. So our coefficients reveal how many particles we have of each. So recall, the place to start would probably be to use what I like to call an inventory. So here's our inventory. We're beginning with a new equation, skeleton equation. So we're going to get away from visualizing the particles and go right to doing this mathematically, because sometimes the particles really get in the way of our thinking. It sometimes makes it a little more complex than it needs to be. So we take our inventory of the elements that participate: iron and oxygen. On the left side, we're going to keep track of how many iron we began with on the reactant side. So what we're going to do is we're going to reveal that quantity by writing a number here. Let me set up the tool so we can draw a little bit. So right now, if I look here for iron, there's only one iron over here on the left side. On the right side, however, iron has this coefficient, subscript of 2. So we have a 1:2 ratio for iron. We know that's not balanced. Let's take our inventory for oxygen, the element. On the left side, the reactant side shows 2 oxygen atoms. On the right side, it shows 3. So these quantities are not balanced. What we're going to do now is we're going to suggest a quantity that would allow us to balance this. Again, there's no, fixed rule about where to start. In this case, I'm going to start with our oxygen. If we notice, we're starting with 2 oxygen on the left, but 3 on the right. So we're trying to put a number in front here that will create the same quantity. Well, this creates a challenge or a problem. You and I both know it doesn't matter what number I put in front here. If I multiply that number by 3, it's never going to be equal to 2. So what we want to think about is where will the 2 and the 3 meet up at? So 2 and 3 are both what we would call factors that would meet up at a multiple of 6. So if I wanted to have a target value of 6 oxygen on each side, what might create that would be a 2 right here. That 2 times the O that's back there makes now 6 oxygens on the right side where the product are. So now we have 6 oxygens on the product side, which means we would need 6 oxygens on the reactant side. But right now we only have our 2. So we want to fix that by adding a coefficient, a multiplier. Well, obviously, the multiplier 3 works, 3 times 2, and that changes our quantity to 6. So we have our oxygens balanced. Notice we had a 2 for coefficient on the right side. That multiplies the amount of everything behind it. 2 times 2 for iron, or Fe, now makes 4 iron on the product side. So we no longer have 2, we now have 4. That means we would need 4 iron on the left side, or the reactant side. Well, we only have 1. We're not allowed to write a little 4 right here because that changes the formula. We're allowed to write a coefficient. So what coefficient would create 4? Well, it would be the coefficient of 4. 4 times the 1 that was already there, right, creates 4 iron atoms. We'd end up with 4 iron on each side, 6 oxygen on each side. We have the balanced equation. So the balanced equation in this case shows a 4:3:2 ratio. So our coefficients, 4:3:2. Let's try it with another example. Again, take an inventory. As you look at this, notice that you have 3 elements in this case in your inventory. So take inventory, list the 3 elements. Maybe pause for a moment and write down what the 3 elements are. So you should have listed aluminum, chlorine, and potassium. Now, what we want to do is we want to take inventory, what we have, or the quantity we have on each side of all 3 of these elements. So let's start with our aluminum. No subscript for aluminum, so that means there's 1 aluminum on the reactant side. Let's go over to the product side. Aluminum, no subscript. There's 1 aluminum. Oh, look at that. Aluminum's balanced. Let's look at our chlorine. Chlorine on the left side, called the reactant side, 3 is the quantity. On the product side, there's no number. So 1 is our quantity, right? No number after the Cl here. Let's look at our potassium, or K. On the left side, there's no number, so there's 1. On the right side, product side, no number, there's also 1. So what is not balanced? Well, chlorine is our only element in our inventory that's not balanced. So chlorine right now is the only thing we need to worry about adding a coefficient for. So we're going to find chlorine over here on the product side. And notice the product side is smaller than the reactant side. So we're going to use or choose a coefficient here. Well, the coefficient we're going to choose, in this case, we're going to choose coefficient of 3. Why 3? Because 3 times the 1 that was already there changes this 1 and makes it a 3. We've tripled the amount of chlorine that used to be there by adding the coefficient. Keep in mind, we've also tripled the amount of K that used to be there. So we're going to need to adjust our inventory for K. Our inventory for K on the product side now has 3. If we go back to our reactant side over here, our inventory still only shows 1K. Well, we fix that by adding a coefficient. Coefficient of 3 allows us to balance potassium. Now, if we look, everything has the same quantity. Reactant side, 1 aluminum, product side, 1 aluminum. Chlorine, reactant side 3, product side 3, potassium, reactant and product balanced at 3. So again, we start with our inventory, and that reveals a place to begin to add a coefficient. So 1 to 3 creates 3 to 1, our ratios. Why don't you pause the video and take a moment to take inventory of what atoms are present and what quantity of each atom or element are present. I should probably say elements at this point. Okay, so hopefully you came up with gallium, chlorine, and hydrogen. Next, I asked you to try to take an inventory. So what you're going to want to do is keep track or write down quantities for each. To begin with, there was 1 gallium on the left side, 1 gallium on the right side. So our gallium's balanced. Let's look at our hydrogen, H. Looks like on our left side, reactant side, there's 1 H. Go over to product side, there's 2 H. So again, on the left side of H, our reactant quantity. On the right side of H, our product quantity for H. That's not balanced. We know we're going to need to fix that. Chlorine, on our reactant side, there's only 1. On our product side, there's 3. We know we're going to need to fix that. So again, there's no hard rules about where to begin. So maybe in this case, we want to think about what a logical place to begin would be. And sometimes that's not quite so clear where to start. So, it's often just trial and error. You pick a place out to begin. And if that leads you to a bad place, you start over. So in this case, maybe we'll think about creating a quantity that will allow things to become equal. And we'll see kind of where that leads us. And if it leads us to a bad place, well, we'll just start over. Okay. So it looks to me like chlorine, right? Chlorine has a quantity of 3. So notice if I put a 3 here for hydrogen, excuse me, a 3 here to balance the chlorine amount, that'll change this quantity here to 3. So now our chlorine would be balanced. However, what will that do to our H amount? Well, that's going to make our H amount also 3. So instead of there being 1 H, now there's 3 H's on the reactant side. Notice 3 does not equal 2. So we know that changing that H to a 3 didn't really help for the hydrogen, even though it helped for our chlorine. So that leads us to thinking, wow, that didn't really work for us. That's okay. Let's just really think about what might have to happen then. Well, what might have to happen is we might have to get this 3 and 2 for hydrogen to come together. And they would meet up at the quantity of 6. So if I sort of use that as a hint to start over, and I think about the goal for our chlorine to become 6, right? We're just going to kind of start over with information here. So originally we had 1 chlorine, we had 3 chlorine, we had 1 hydrogen, we had 2 hydrogen. So in my mind, I'm thinking that I might want to make 6 chlorine because we weren't able to make chlorine balance before. So 6 times the 1 chlorine that was there to begin with now creates 6 chlorine. If we want to get 6 chlorine on the other side, however, right, the coefficient we would place there to multiply Cl by would be a 2. 2 times 3 would make the 6 chlorine we need on the right side. So look, we've balanced our chlorine. What we've done, however, is we've changed the quantity of our gallium and our hydrogen, and we're going to need to go back and check that now and fix that or correct it. So let's do that. Maybe let's do it for gallium first. 2 times the 1 for gallium on the product side, that changed our gallium amount now to 2 on the product side. On the reactant side, however, there's still only 1 gallium. So that's a simple fix. The coefficient or multiplier of 2 fixes that. That balances our gallium. And what we can now do is notice that gallium is balanced. The only thing that's not balanced right now is our hydrogen atoms. So we notice when we put that 6 in front of HCl, that made the quantity of hydrogen multiplied by 6. So there was 1. Now actually on the reactant side, there are actually 6. So that means the target for chlorine on the right side should be 6 over here on the product side. Well, isn't that what we did? We created 6 by placing this 2 there. 2 times the 3 that was back there already made the 6 we wanted. Wow, look at that. It's balanced. It's balanced with coefficients 1, 6, 1, 2. So our coefficients in this case, 2, 6, 3, 2. So if you'll pardon my error here, one thing that we failed to recognize is we failed to recognize that our hydrogen amount over here on the right, I didn't put our coefficient in here to create the 6 on the right side. Our coefficient of 2 belonged only to chlorine. So to get what we needed for hydrogen, our coefficient should have been value of 3, not a value of 1. So our coefficient, 3 times 2, creates the 6 hydrogen we need. So 2 to 6 creates 3 to 2. So simply taking what we call an inventory allows us to begin to understand what to do by adding coefficients. Recall that a coefficient becomes a multiplier, but a coefficient only belongs to each chemical. Let me kind of state what I mean by that. So let's reveal this writing tool here. We put the coefficient 6 in front of HCl. That means 6 only belongs to HCl. We put the coefficient 3 in front of H2. 3 only belongs to H2. We put the coefficient 2 in front of GaCl3. 2 only belongs to GaCl3. We put the coefficient 2 in front of Ga. That 2 only belongs to Ga. So it becomes a multiplier only for the reactant or the product that it belongs to. I hope that you'll take the time that you need to do the follow-up practice assignment that relates to this and put an honest faith effort into it. So this will be the beginning of a few lessons that will tie together to help give you better skills for what we call balancing a chemical equation. So for now, if you'll take the opportunity to review this multiple times if need be, some of you might want to go back and review it. So you can, at your time, review parts of the lesson. that kind of help you understand what to do next. So until the next time,
everybody's choking now. The clock's run out. Time's up. Over. Loud. Snap back to reality. Oh, there goes gravity. Oh, there goes gravity. Choke. He's so mad.
so until the next time, I bid you peace, and we'll be talking to you soon. So do yourself a favor, legitimately try that practice work, because I think it will help. So we'll have some follow-up where we can give you some feedback about some of the challenges that you're having, but it's sort of normal to have some challenges with this when you first start it. So do me a favor and wrestle with that idea a little bit. Those of you who wrestle with the idea, you'll begin to develop a little bit of a skill set for what this is really all about. So once again, like I said, to the next time, I bid you peace.